Hello, Dumelang, Sanbonani, Molueni, and a warm welcome to the Maths Genius video tutorial series brought to you by SABC Education. In these tutorials, we help you unleash the mathematical genius in you by showing you key mathematical concepts and how you can master them for success like a true genius.
Today we're going to be looking at applications of exponents in algebraic expressions. So I'll just use this one example to show how you apply those length laws, right? Remember the laws of exponents? So you should be able to identify them when they do exist. So let's start with the first one. If you look at it, it's saying 30x to the power of 20, y to the power of 10 divided by 10x to the power of 5 over y, right? And everything is being multiplied by the other term, which is 3x squared to the power of 4. So there is no order to say start with this law or start with this one. As long as you are obeying BODMAS, as long as you are obeying the laws of exponents, there is no problem. So for illustration purposes, I'm going to rewrite this in such a way that we can be able to visually see what's going on. So it's going to be equal to 30x to the power of 20, y to the power of 10. I'll put the divided like that, okay? But it's not necessary to do it that way. You can do it whichever you feel comfortable. Multiply by 3x squared to the power of 4. Right. Now, once we've got, we understand what's going on, right? We look at our terms and say, which ones have the same basis? Because for you to be able to use the rule a to the power of m divided by a to the power of n is equal to m minus n, the bases have to be the same. So in this case, if you look, the coefficients, they can divide, right? They can divide because they are all real numbers, right? They're both real numbers. Then, if you look at the x's, they can divide also because they've got the same base, right? So, 30 divided by 10 will give you 3. So these two have cancelled out, right? So you have a 3 there. Then x and x. So this is the same base, division, so we subtract the exponent. So it will be x 20 minus 5, right? 20 minus 5, we're using this rule here, the laws of exponents. Then when you come to your y, you check again, you see, same base, division, therefore subtract. But remember, y to the power of 1 is the same as saying y, so you know that there is a 1 there. So y to the power of 10 minus 1, like that. So we have applied these two laws to this problem so far. Multiplied by, I'll just put the brackets like that, multiplied by, but now if you look here, you'll see that it's a power of a power. And we know from the laws that a to the power of m times n will give you that. So power of a power is multiplication. So we can multiply 2 and 4. So that means that this is multiplied by 3x to the power of 8. Right? So far so good. We've used 3 different laws to get to where we are. So we can do the subtraction here, right? 3x to the power of 15, y to the power of 9 multiplied by 3x to the power of 8, right? Let's go again and see. So the 3 and the 3 can multiply, right? They're both whole numbers. 3 times 3, it will give us 9. So that's done. Then there's this x times x, right? Same base, multiplication. So it's going to be x to the power of 15 plus 8. And then because there's no y here, so it's just going to remain the same, like that. So it's going to be 9x to the power of 23, y to the power of 9. That is your final answer. So just to recap, you used different laws of exponents to simplify this expression, of which the x and the x were able to subtract the exponents because they have the same base, and there was division. Same thing with y, and here there was a power of a power, so that's why we were able to multiply and get 8. And then we were able to multiply this x and that one here because they have the same base, so we added their exponents to get 23, and y remained the same because there's no other y that we're multiplying with. So this is just a simple illustration of how you use the laws of exponents when faced with bigger equations or bigger algebraic expressions. Thank you very much.
Thank you for taking the time to watch this video. Unleash your mathematical genius today. If you have any maths questions, you can post them for free on www.mathsgenius.co.za or email them to info@mathsgenius.co.za.